Okay, we're going to review how to go over the right tail, left tail critical values um, for your hypothesis testing procedure when you have a large sample. Now, um, what I have here for you guys is the various level of significances for alpha here. And remember, you got the 10%, 5%, 1% level of significance. So here is 10%, and all of that is in the right tail. So we want to discuss here how we got a critical value here of 1.28. So this is what we want to look at here. And this is for the 10% level of significance. So alpha here is 10%, which is 0.10, by the way. And all of that 10% is in the right tail. So if we're going to use the Z table here working backwards, we need to know what percent of the bell is shaded in red. Now, if you remember, we take 50% minus 10%, and that gives us 40%. And 40% is written as 0.400. So we're going to be looking for, on that Z table here, 40% there. We want that 40%. So on the Z table, if I go back up here, I believe I put it down here, 40%. We want to get to as close as 40% as we can. So if we look here, the closest to 40% we find is right here at 39.97. So we're going to have to find that Z value. So the row that this value is in the 1.2 row. The column that 39.97 is in the 0.8 column here. So the Z value will be 1.28, and that's as good as you can get for that 40% here. So this is why the Z score is 1.28 here. And we call that Z score a critical value. So ladies and gentlemen, for this first question here for alpha 10%, this is why they have 1.28 as that critical value. Now, I just want to remind you guys, because of symmetry on the other side here, by the way, just to use that symmetry idea, for a left tail being 10%, my Z score is going to be on the other side, and it's going to be to the left of 0, which makes this a negative 1.28 for the critical value. So that will be for the left tail. So I'm going to use symmetry, ladies and gentlemen, to find that left tail. So if you said, why did they get a negative 1.28 for the alpha being 10% on a left tail, and I have the left tails down here. Okay, so we have the left tails as well, 10%. That first alpha being 10%, we see 10% of that area is in the left tail. We see the critical value being negative 1.28. So I'm going to use the concept of symmetry. So if you have the right tail value, you can get the left tail. They're related here, and that's how they're related because of symmetry. Remember, only one table that you use. You only have to use one table if you remember symmetry. So you might say, okay, what about now if all of alpha, the level of significance of being 5%, is in the right tail? Okay, so we're going to go through the same process. We're going to say, okay, 5% is 0.5. We need to know again what percent of the bow is shaded from 0 to the z-score. So we're really trying to find what percent that would be. We start with 50%, we subtract the 5%, and you'll get 45%. So ladies and gentlemen, 0.4500 is what we should see shaded here from 0 to that z value. So that's 45%. So you might say, how did we get the 1.645 as that critical value for this right tail? Right? And it's going to come from this idea here. We're going to look at the z table, and we'll be working backwards on the z table. So this time we look for 45%. And we're finding 45% here, and you go, oh, wait a minute, 45% is right in the middle between 44.95 and 45.05. That's where 45% would be. So we'd say, is that where 4500 would be? It would be. And if you follow the arrows, they know, or they knew, you were looking for 45%. So this is 45% right here. And so the z-score associated with that 45% is, in fact, 1.645. So if you said, is this how they got 1.645 for the critical value for the right tail? And I'll say yes. And this is how they got it. Remember, these are z tables here. This is a z table. And because of symmetry, we can think of the left tail. If we had a left tail test, and they put all of alpha being 5% in that left tail now. So because of symmetry, and I'll write the word down again, we only have to use one table. So this will be negative 1.645 on the other side. If this were a left tail 5% scenario, that will be my critical value. It's going to be negative now. So if you said, oh, did we summarize that down here as well for the left tail? And the answer is yes. For left tail, you can see that critical value is negative 1.645, all because of symmetry. So we're going to use these critical values in our hypothesis testing procedure. So that leaves us with the last situation, meaning 1% level of significance here, 1%. So now over here, we're going to look at the right tail, and then we'll do the left tail. All of alpha, 1%, is in that right tail. So to find again what percent of the bow is shaded here in red, we take that 50%, we subtract the 1%, and that gives us 49%, and 49% is 0.4900. So we're going to look for this value here. This is 49% from 0 to that particular value, z-score. So if you said, how did they get 2.33 as the critical value? How did we get this? Well, go to your table for 49% now. Now we're looking for 49% here. So we're going to have to search here, 49%. So we look and we look and we look and we go, wait a minute. 49%, no, that's not exactly 49%, but that's as close as we can get in this table. That's 49.01. 49.01, that's only 1 penny over. Yes to the right is 4 pennies over. Yes to the left is 2 pennies under here. But 49% is good enough. So it's pretty close anyway. It's in the 2.3 row. Zero 3 column. So, ladies and gentlemen, 4901, which is close to 49%, is in 2.303, 2.33. So, if you said, is this how they got the critical value of 2.33? And the answer is yes. This is how they got that 2.33 critical value. Right in here. Now, by symmetry again, if they happen to give you a left tail, 1% of that alpha is now in the left table. And because of symmetry, this is a negative 2.33 as a critical value if this were a left tail test. So we just use symmetry. Put the mirror across the mean of 0, reflect the right side to the left side. So that's going to be a left tail critical value. It's negative now. So what I did place here as well for you guys is exactly that scenario. 1% is in the left tail. Notice your critical value, sure enough, will be a negative 2.33. So I want you guys to remember here these values. Keep these things in your notes here. Keep this. I did update your hypothesis testing notes to fix any errors and go over these scenarios here. I put the right tail before the left tail. And so this is updated. So I would like to say, keep this stuff in your notes, print them out for yourself, because you're going to be using these critical values for left tails. And so it's important that you know them. And you're going to be using these critical values here for your right tails. So I went through exactly how we got them. I'm going to erase this now. So this is a short video on how we got them. Look at how fast it was to do this, how to go over all that to get this information anyway. Pretty quick for you. So if you want to review that to see where this comes from, please do. But this is in your notes. Keep them handy, print them out for yourself. And this is how we got those all-important critical values. So I hope you guys enjoyed this demonstration. I'm going to put it online and send it to you in the announcement portion.